1 2 1 2 1 2 1 2 1 2. Woo! So let's try to put this thing through it and see how it fares. So let's see how it fares with this one to figure out how we go ahead to cook lowest. Let's do a quick check. Well, I think we don't necessarily need a quick check. We could use the proper one. I think we have a common ancestor for here, and then we could pin this here and then see how that compares. Right? So let's cook. So now we are going to just be transversing through it to see how the two compares, right? And how the lowest common ancestor like does his stuff with real data within the debugger tool to show us that. So what did we pass in? We passed in D and E. So basically we are going to see it in action right now. So let's jump over that, jump over this, and then we step into this guy. Now stepping into it, we have A, right? We could see our A and our B, right? This is D and E, right? Our two special characters, D and E, and then we jump over this, we find L and L. You can see that it returns us an L and L as our path to A, right? Left and left is our path to A from the head of the node, and then this guy which is left and right is our path to the head from the node. Left and left, left and right is our path to E from the node. You can see it here. E returns left and right. D returns that's a special character. So path to B. So who is A? Okay, it does not do this thing within it. Okay. So path to A basically is D, obviously from our function this thing, our function props, or yeah, our function uh variables. So we take in A as E. That's the name of the real. That's basically the value of the node, not necessarily the node itself, right? But the values of the node. And then we say that this is left and left, and then this is left and right. And then after passing that in, so this is our left and our right, and we could see that our path to A, which is D, returns a left and left, and the path to E returns a right and right, which you could see here, a left and a left and a right and a right, a left and a right rather. I think I made that mistake there. So now we instantiate our I as earlier said. Then the root of our project this thing is pointed to current. So basically this guy here pointing to current. Now we instantiate our range, right? Saying I in range length this minus 1, length B minus 1, and length A minus 1. So basically that length is, I think we could see something from there. So our length is 2, and minus 1 would give us 1, and our length over here as well is 2 again. This thing will give us 1, and yeah. So we now say also that the path of A and the path of B at that index must be the same. So let's step into it, and we step into this. So we could close this down so we could see some other variables like I and see them increase. So direct path of A is what? L. So we don't need to do any comparison again. We've already made sure that before this while loop exists, that A at the index of I and B at the index of this must be the same. So we just need to pick out the part of 1 and then use that as our transversal. So we go through that. We now say direct equals to L, right? Because at the index of 1, right? You could see here at the index of 0 rather, we have L. So it is L. This condition is met. We step into it and we go to the left. Now the right is not met, right? So that would basically run through. Now our while loop, our value is now 1. Our range still we are still within range because our length is 2 and our I is 1. So our basically the range is going to be 0 and 1. This is I is within that range. So we continue into the while loop, and I should have stepped into that, but basically the same stuff that happened before, and we see our our we see that, but basically, okay, yeah, even in that instance, the while loop is not even going to be adherent anymore because this guy is not being met anymore because this is left and right. Meanwhile, at that index of I, which is 1 now, this is left, but this is also, this is now right. So this in this condition is not met. So the while loop will be jumped over, and then we could easily come and return our current to be the then current dot left, which is B, which we found here. So we could see that we are pointing at current right now, and I believe our current should have returned over here. So the value of our current is B. So we could see it here, right? So the value of our current is B, and we are the B guy or the B node, and basically we can return and be happy that we found the lowest common this thing, lowest common ancestor.